Okay, I have started. Okay, so this is great. Uh, so we have about, I will say about half an hour or less left. And the plan is, actually the plan was to start 12.2 and then 12.3. But we are really slower because we are online. So if you don't have any question, I can just continue the lecture. Oh, no. Sorry. Somebody asked me something else. I forgot to answer that one. Can I answer just after starting this one? The what is Luke asked me.
Oh yeah, that's fine. Go ahead.
Yeah, okay. So later I can answer that one. Yeah, Luke asked me whether I can try any other problem to just set the limits. We will have many of those. Okay, because that's the only job that we need to do in this chapter. Just graph, set the limits, and integrate. As of now, it seems we've seen only the region of integration to be exactly rectangle region, and the reason is just in this case your rectangle region is easier to integrate. So if you have from A to B and then you have from C to D, so that's just easier because everything is constant. So but you in general that's not the case, right? So you just have maybe lines, and then you need to get the integration of this piece, or you might have the half circle and then you need to get the integration of this piece. So then if I have half circle, this is just something that I will say from, for example, 0 to 1, but I can't say the whole thing is from 0 to 1 because that will be square, right? So that's just really not the ending point. Okay, so then how do we do this job or setting the limits of integration if it's not really everything constant, if not really these 2, 3, 4 lines, the limits of integration? So then you want to do it in general case. Okay, we call it just do the double integration in general case, but it's not really that much general. We have very limited options to integrate if it's just not square, if it's not rectangle, or if the limits are not constant. And then we have terminologies for this type of general region. As I said, it's not really that much general. It's just somehow can be written in some cases. Okay, so this is just reminding us, if you have any of the region like this, that's not really easily to just say, okay, I have started from right here and then I ended by here, and then that's just the constant part. And then how about this piece? So this is not really constant. It's
not exaggerating.
by the graph, right? Is there any question? No. Okay. So if you have any problem at home like me, you can mute the mic for a while and then come back again. But don't worry, okay? Don't just let her do what he wants to do. That's just their kids. That's fine. This is the advantage of being at home. So just mute your mic if you have any problem. So what I want to just call general region is just either type 1 or type 2. So the cases that we are able to set the limits of integration is going to be always when you have this first one to be constant. So it's just either x to sit first or the y to sit first. One of them must be number, one of them must be lines, one of them must be constant. Then we can integrate. If you have both of them at the same time constant, you do not know how to integrate unless you cut it to the pieces to make it in any of these constant lines. Okay, so for the type 1 integration, so for this one, which is the type 1 integration, so we call it type 1. And then as you see, in this case, your x's are constant. So if your x's are constant, so means you have started from the line to the line, constant, line to the line, as you see, but the y values are not numbers, they are not constant. This seems is just really, they are making curvy shape, okay? So they are making this curve shape, this curve shape, this curve shape, this curvy shape, curvy shape. So this is what we call type 1. And then as you see, whatever is first is the one which is constant. So since this type Your x's are constant, so you write x's first. So this is must be first, but integrate last because you started from inside. And then that's just your number one. Then the limits of integration for number two, which is whatever is not constant, is just really when you make the motion in that direction. So let's say if I want to move on the direction of the y, this is the first line or curve that I hit, and this is the next line or curve that I hit. So the first one sit first, the last one sit last. So, or you can say whatever is down is smaller than whatever is up. So this is lower limit, this is upper limit. Or you can say I have started from the negative, I moved, I hit this one first, and then I hit this one next, okay? So the order of integration is telling us always the number one must be constant. So whichever is constant, I just write it first, but whatever is not constant, I have to make this little arrow to see which way I'm increasing and what's the limits of integration in that direction, okay? I can switch the order of integration when do it exactly same way in type 2. What's the type 2? Type 2 says, how about if the y is constant? So the y value could be constant too, right? So if the y value is constant, that must be first. Now the order matter. Now the order matter, I can't reorder it however I want because I have to be careful. If I'm switching the order of integration, somehow I need to have the list. So somehow I need to know this is the constant, this is a constant for the y. So these two are constants, so these are lines, these two are constants, so these are lines. So this is sitting first. And then I just say, okay, so what it is, you're just supposed to integrate of the next 10 is for the x, so means you are moving on the x direction. So this is your x direction that you are moving. So first thing that you hit is here. Last thing that you hit is here. So you're having first left side is lower limit, right side is your upper limit. Left is your lower limit, right is your upper limit, okay? So then you can set the limits of integration. But the main thing that I have to remember is if the first is not number, you can't integrate. That's not true because you will end up with the variable, but you must end up with the numbers at the end, okay? So when we call it general case, it's not really that much general. At least one x or y must be constant or between two lines in the graph, then you can just integrate it. And then whichever is just first, which was the constant, is actually the last because you start from the inside and integrate in terms of x and then you go out. Does it make sense? Is there any question? Is there any question? No? Is that fine? Move on. Hey guys. Okay. So this is a good example, right? So what is good about it? Because first of all, do I need to know how to graph the three-dimensional? No, I don't have to know what's the graph of this one, because to set the limits of integration for now, I need to just know where are the regions. So the region of integration needs to be either type 1 or type 2. So if I see this two-dimensional graph, and I'm sorry because as I said, this PowerPoint doesn't get this square correctly. So these are x squared, these are x squared, that's the power. So if I know how to graph it in Calculus 1 or just how to make the parabola in two-dimensional, then I see the limits of integration. So this is just your first step. Always you need to draw your domain. And then if I have the graph, so like as I learned in calculus, I mean in algebra classes, I need to decide, okay, that's just the y equals to x, and that is 1 plus y equals to x. Okay, so this is not a nice graph. All I need is the intersection of them. But I've learned in in algebra class how to get the intersection. So let's see. 1 plus x squared was curve number 1. 2x squared was curve number 2. So then I have intersection of these two. So that is x squared. So then x is going to be plus minus 1. Yes, the intersection is symmetrical between -1 and +1. So this is just the basically region I'm looking for. So this is the region I'm looking for. And then the question is, can I fix the x, or is the fix the constant one? Obviously, this is not rectangle region. This is not a square region. These are really between the curves, okay? But at least I need to decide one of them must be constant. Is the x the constant one, or is the y is the constant one? Any idea? Yes, that's true. Exactly, x is the constant. Okay, so that means you are having a type 1, right? So you are having the type 1 because x is constant. So then I will just say, okay, you have to integrate from dx first and dy next. So what's the limits of the x? The lowest, the smallest value that you see, that the largest value that you see. So you have started from -1, constant, okay? So remember, the inside one is the constant one. So you have started from -1, and then you have ended with the positive one. So then if I can change the color, I need to take care of the y next, right? So I need to take care of this y next. So in order to write the limits of the y, you have to move in the y direction and say, this is the first one that I hit, this is the last one. Or you can say, the lowest one is this one, and then the highest one is this one, okay? So what's the one that is the lower one? The one that is passing the one, I think blue is more clear. So the one which is passing to the origin, it seems is the lower one, and the one that is 1 unit shift is just the upper one. Okay, so I have started from this one first, and then this one last. So that tells me the lower limit is going to be y equals 2x squared, and the upper limit is going to be 1 plus x squared. And then I have to integrate in terms of y, and then whatever is the function. Any question by now? Is there any question? And again, this is 80% of the job. If I can just graph, and if I set the limits of integration, if it's just really 10 points, you'll get 8 out of 10 because of these steps, okay? So this is the main job. And then the integration is nice to practice too. So I have to keep this -1 to the one outside, and then first take care of the inside, which is x constant, y variable, right? X is a constant. Integration of sine is going to be cosine negative, right? So you have to plug in these two values. You have to plug in these two values. So this is same minus 2x. If I plug in cosine y value to be, let me change the color. So y value this time is plugged in to be 1 plus x squared, and then subtract minus is plus, and then I have 2x, then cosine, the y value this time is going to be 2x squared. Okay, and then that's just my next integration. So this is the next one, which is really calculus one, means is single variable. So I have to use the u substitution to integrate. So to do the u substitution, I call this one to be u, and then I call this one to be u. Okay, so this is your u. So then the du is going to be 2x dx. So remember, for this one, we don't want to really see the steps of u substitution, especially you don't like to just really change all the limits. You can just do this part somewhere here in your scratch work. So I am doing just cosine of u, and then that factor is going to be exactly my du, and then the integration of the cosine is going to be sine, and then plug in the values. But before that, you can just really say u was what, 1 plus x squared. Okay, so it's a place that I just really recommend you don't do the steps that much here in the integration, because it takes it's long and you might do mistakes. Okay, so that's why I want to say, for now, I will do all these things that I've done on top in my mind or in a scratch work, and then I end up, sorry, because I integrated, I have to erase this one. So then I end up with what? So I have cosine, integration of cosine is sine, and then u was 1 plus x squared, and then you have to plug in negative 1 to the 1, and that's just negative. I transfer the negative, and same u substitution the other one, but you don't need to show the work of u substitution here because it's really same as top. I don't know what is the du, so I just write the du is going to be 4 times x dx. So this is going to be 1/4, huh? So if I write over here, I have to say x dx is 1/4 of du, right? So I will write over here, I have had 2, and then I have had 1/4 of the du, or I can just say directly was 1/2, that's fine. And then I have to just write this second part, which is integration of the cosine, which is sine. That is going to be sine of 2x squared, and then you go from negative 1 to the 1. Okay, this is the integration. This is just the u substitution. You can just plug in, and then you can just find the answer. Okay, any question? First of all in limits, and then in u substitution, which was something from calculus 1. Do I have any question? Anything, guys? No, so it's fine. So this is just really not nice, I will say, not nice number, because I have to plug in 1 plus 1, and then I have to plug in 1 plus 1. This is why this cancel out. It just really symmetrical, I believe, so it's 0, huh? So since it's symmetric over negative 1 to the 1, so that is just going to be nothing left, right? So that's why this cancel out, and that gives you 0. This is it. Did I miss anything? How long to be posted? I don't know, Brooke. I think for the morning one, I still haven't received the, which is really about 4 hours. I haven't received the link. I hope it's not any technical problem. But I know because it's a long one, it takes time because it needs to be recorded. Yeah, always. Yeah. Always posted online. Okay. I think Uh, I think since we are really doing slowly, if I want to keep the same number of classes, sorry, why no one is talking? Just talk, please, guys. It just really, everything is mute. I feel you don't see the question when I'm answering. So now I'm answering the Leslie question. Is there any lecture during the spring break? I hoping not, but I think we have to, because it's just really getting so slow. It's getting so slow. I don't want to just really go too much fast, at least for students who are making this classes. But since I'm a little bit slow, so I think I have to keep going, unless I just add one more session. So not really Monday, Wednesdays, sorry, Tuesday, Thursdays, just really one more, maybe on Fridays or somehow, to keep it on the track. I don't want to miss anything. It seems I am really slow. I supposed to finish to 12.32, but we just barely start 12.2. If anyone is watching, I think that was fine for mine. If not, just for Darian, if you just search it on the what is Google, you can find him, and those are really great videos. I like them because it has many examples. It is long, I agree with that. If you have time, you can watch it, but that's many examples. You will see many examples there, which we don't have time to do it here. The schedule is not really that much important for making the classes, because everything is recorded. If anyone is missing any part of the lecture, you can watch the missing part later. So the schedule of the classes is the same, but if for some reason anyone can't make these videos or that just this meeting time, so always go back and watch the links on the what is Titanium. So it doesn't matter who has which class. That's just the advantage. You know, ideally, if students can watch the videos on the Titanium and later come back here and ask questions, so we can do more problems during the meeting, or this 2 hours meeting that we have every Tuesday, Thursday. But as I'm doing right now, I'm just really scheduling, I'm just teaching right now. I don't know, right? So if I just start to teaching as I'm teaching in the class and you like this method, so then you have to stay more than the class time to ask your questions. But always, if you don't ask questions, there is nothing to do with me, right? So that's just really the main purpose of having face-to-face classes, right? So you want to see your professor, you want to ask the question. So anytime you have any question, always email me, always request for another Zoom meeting, and then I will just really find the time to make it. And you see, you're saving time. We are saving time because we don't drive to the campus. It's about 1 hour. So this means you can stay on this Zoom meeting more than whatever was the regular time, because that's just really saving a lot of time for driving, finding the parking. So you can make really this, I can make really these videos to be more than 2 hours, because it's saving time for us to answer the questions, not just really lecturing. But the ideal was just really to watch the videos and then come back here to ask the questions. Really, our next test be in the date going to change? I don't have answer for this one, book, sorry. How are office hours going to happen? Same is here, right? So it's just really making the online office hours. So we will have the time. I can make the same times that I was in the office, but I think it would be more useful if you request through the email any office hours, and then I make a Zoom office hours for you. That's just more useful. Any other questions, guys? Sorry, I'm answering only questions. I don't reading the main questions that you're asking because it says to everyone. So again, for any type of this discussion, for now the option is the Zoom, and that's a really great option. And then, as I said, I will record it, and then you will have access to this one, and you can record it too. For now, that was the lecture. But again, since I'm doing really slow, somehow we need to find a solution. And then I will encourage you, please watch the other videos. Okay. So again, if we have a meeting tomorrow with the department chair, we will answer the questions about the exams, and then how we can work with this scheduling if it is too slow. Yeah, what was it? Was this the problem we're going? Huh? Was this the last problem we are doing for this lecture? I think it's the time, yeah. We have to finish it. We have to close it. Any other question, guys? I'm going to